these topics were very successful. There was a lot of experimental success in these fields, and so of course they progressed, of course they advanced, and of course we came up with all of this more progress in those fields, okay? So anyways, speculation or work with extra dimensions just did not have too much breakthrough between 1920s and 1960s. Good night, Doro. Thank you so much. So, with physicists exploring powerful quantum methods, the implications of which gave rise to experimentally testable predictions, there was little interest in the mere possibility that the universe might be a vastly different place on length scales far too small to be probed by even the most powerful of instruments. But sooner or later, bull markets lose steam. By the late 1960s and early 1970s, the theoretical structure of the Standard Model was in place. By the late 1970s and late or early 1980s, many of its predictions had been verified experimentally, and most particle physicists concluded that it was just a matter of time before the rest were confirmed as well. Although a few important details remained unresolved, many felt that the major questions concerning the strong, the weak, and electromagnetic forces had been answered. The time was finally ripe. You are now redeemed from your sin of not mentioning Madagascar. Oh my gosh, thank you so much. Acacio, are you from Madagascar? Is that where you're from? So, the time was finally ripe to return to the grandest question of all, the enigmatic conflict between general relativity and quantum mechanics. And so, this is when people decided maybe we can go back to this original question and remember Kaluza and Klein. Remember those bold people who had injected one extra dimension and shown some progress in unifying gravitation with electromagnetism. Now, there were some things about that theory that was kind of wrong because they got the electron mass and charge wrong, but oh well, things happen, and maybe they should have just been given the opportunity to update their theory and refine it further if they were given that opportunity, or research grants or money or time or energy of day. So I think this is kind of where people started to go towards. Poor Kaluza and Klein, So the time was finally ripe to return to the grandest question of all, the enigmatic conflict between general relativity and quantum mechanics, the success in formulating a quantum theory of three of nature's forces emboldened physicists to try to bring the fourth gravity into the fold. So another thing is, which did not happen by the time Kaluza and Klein were doing their extra dimension stuff, is that the unification of the non-gravitational forces that I mentioned earlier, the unification of electromagnetism with strong and weak nuclear forces when you go to some very extreme temperature, energy, or length scale, very tiny length scale. We spoke about that. Remember, it was this unification that then required a little bit of help or little touch of supersymmetry at the very end in order to be good, right? In order to really truly unify those three. So this unification work happened later on, right? Later in the 1900s. So this was not there when 1919 was happening and Kaluza and Klein was doing the extra dimension stuff with Einstein's general relativity. So this also made people more bold and wanting. It's kind of like you already did 3 or 4 different chores out of 5. Then you feel much more emboldened to do the 5th chore and just be done, right? And so because they had already unified the 3 of the 4 fundamental forces, now of course they want to keep going and try to unify gravitation with the 3 fundamental forces that are already sort of unified under particle physics, supersymmetry, and all that. Hello, Grimmy. Thank you so much for being here.